All right, guys, this is the last one. We're going to look at the calculus of motion, calculus of forces, and just encourage you guys. All right, so here we go. So we've got a particle undergoes variable forces. So they end up with 12t minus 6t squared. Okay. So the first question is, when is the particle at rest? Well, that part A is going to happen whenever the velocity is 0. Okay. So what I want you to do whenever you do this, factor out common variables. Sorry, common factors. So I'd end up with 2 minus t. So I would get an answer for this with two options, either when 6t equals 0, so time is 0, or when 2 minus t equals 0. So that's going to happen, I just wrote it again, when the time is 2 seconds. So it's at 2 moments, the velocity is going to be 0. Okay. When does the particle change direction? Okay, so part B. Anytime you have a velocity of 0, what you can do is you can look on both sides of that time and see what it's doing before and after. If you're to plug in like a time negative and a time of 1 second and a time of 3 seconds, you'll see that it keeps alternating. And so when that happens, you know you have a change at these sweet spots when it's going to be zeros. Okay, so when you have a velocity of 0, that's a key in that it's probably going to be a spot where it changes direction. Part C is, what is the particle's acceleration? So my acceleration is going to be the derivative. So my acceleration will be 12 minus 12t. So that's going to happen at, nope, I'm not solving for that. Instead, I'm asking for, what is the particle's acceleration at 3 seconds? So at 3 seconds, what I do is I just plug in 3. So I get 12 minus 36. So I get an acceleration of negative 24 meters per second squared. Notice how when we have the acceleration at that moment, I can find a force at that moment. So if I do an F equals ma. Okay. Part D is, what is the velocity at 6 seconds? Well, guess what I do at 6 seconds, right? I just plug it in. And that's it. Now, part E, we're going to give us some space. So part E asks us, how far did it go? Okay. So to go and find out how far it went, I need to do the integral of the velocity in terms of time. Okay. So how far it goes is going to be the integral of 12t minus 6t squared dt. Now, I want to know from 0 to 2 seconds. So I put in 0 and 2 seconds. So what we're going to do is we're going to add a power, and divide by power. So I get 12t squared over 2 minus 6t cubed over 3. And I'm going to do this from 0 to 2 seconds. So I'm going to simplify so my math's a little bit easier. So I get 6t squared minus 2t cubed from 0 to 2. So now all I do is I plug in these two values. So the final time is 2. So I do 6, 2 squared minus 2, 2 cubed minus my initial time, 6, 0 squared minus 2, 0 cubed. Okay, so I end up with 24 minus 8, 16 minus 0, so I get 8 meters. Now, if I go back to the problem, where did I start? I started at 4, and I changed by 8. So if I started at 4, and I changed by 8, that means I ended at 12 meters. All right. Calculus of forces. If you notice at the bottom, I did not put drag on there because we had that whole handout dealing with drag. So if you're wanting more work with drag, that's where I want you to go. All right, so this one is, we've got ourselves 3 problems, okay? 40 kilogram object experiences a variable force. So force equals 4t. Starts from rest. What's its velocity at 20 seconds? Okay, so F equals ma. So I'm going to write it as ma equals 4t. So mass times acceleration is 4. I got to stop writing the same thing again. I think I need to go to bed. Okay, ready? So acceleration is 4t over m. Okay. Well, acceleration. Well, how do I get velocity? I take velocity is going to be the integral of acceleration in terms of time. So what do? I take the integral of 4t over m dt. Now, the key here is 4 and m are constants. So I can pull them out. So if you look, I can just say velocity is 4 over m. And now I take the integral of just t. So I get t squared over 2, which gives me 2t squared over m. In this one, I know my time is 20 and my mass is 40. So I get, I believe, 20 meters per second. If I'm wrong, please let me know again. I've made lots of mistakes. Okay. 2 more, guys, and we're out of here. All right. Position of a toy locomotive. X equals t cubed minus 6t squared plus 9t. The net force of the locomotive is equal to 0. Let's think. I want to know when the net force equals 0. Well, to find the net force equals 0, I need the acceleration. Well, how am I going to get acceleration? Well, I'm going to take the derivative. Well, velocity is 3t squared minus 12t plus 9. Well, if I get acceleration as my next step, I get 6t minus 12. So the question is, when is the net force equal 0? That happens when since F net equals ma, that only happens when my acceleration is 0. So that's going to happen at 2 seconds. Okay, so let's see option B. Okay. Last one is, notice how I set it up. I set up a lot like an FRQ. So now I've got a 6 kilogram particle experiences a variable force of 5. It's F equals 5 TV. Okay. Write a differential to solve that we could solve. So I'm just going to rewrite F. So F is going to be my F net. So F net equals MA. Now, acceleration is dv dt. Okay. I have V's on top over here. I need to get that V over. So I'm going to do 1 over V m dv dt equals 5t. The next thing I'm going to do is, see I have t's on the right side. I want to get that dt up on top over there. So I got 1 over v m dv equals 5t dt. This is called a differential. What you've done is you've separated your terms. That is something you could solve. Okay. So now we're going to solve it. That's the next part. But just like an FRQ, just setting that up and recognizing those relationships. Man, if you could just do that, that's awesome. Okay. Mass is going to be a constant. 5 is going to be a constant. Okay. So I'm going to take the integrals of both sides. But watch. Mass is going to pop out because it's just a constant. 5 is going to pop out because it's a constant. So I'm going to do the right side. It's a little bit easier. I add a power and divide by a power. Okay. The left side is a little bit trickier. So if I add a power, nothing works. So remember, it's on your equation sheet, but the integral of 1 over v is natural log of v. So you've got a really good setup right here. Okay. So you've got, let's get this guy out of here. Now let's get this guy up to the top. So now what we need to do is we need to solve this for v. So I'm going to divide both sides by m. So that means I got 5t squared over 2, that's squared, I promise, over 2m. Exponentiate both sides, and I get v equals e to the 5t squared over 2m. Okay. These problems down here, I just want to remind you of 2 big ones out there. Is we've got the ones where it's like you have a car that slows down. We have those in our packets. Physics Olympics, remember how we had the FRQs at the very bottom? And then the bonus, draw the forces on a balloon traveling over Montana. And with that, I leave you with one of our. If you've made it this far, you deserve this little treat. Thanks for tubing in. See you on the other side. Yeah. Enjoy. Beautiful song.